Hello guys, in this video I'm gonna demonstrate for you a very important theorem in electric circuits which is called the superposition theorem. Okay, this theorem is very like intuitive, and once you learn about it, it's basically clicked in your mind. So it makes sense basically, even without a proof. That's what I want to say. So it is very simple, and very simple concept. It is just said that the power consumption or dissipated in any circuit element is because of all the sources in the in the circuit. Okay. So let's have an example. Like for example, in this circuit in here, okay, we have like three elements: the 2 ohm, 4 ohm, and 8 ohm, and we have two sources: the 40 volt and the 9 ampere current source. Okay, so any power dissipated in any resistor, like the 2 ohm, 4 ohm, or 8 ohm, this power is coming from two sources. The 40 volt voltage source and the 9 ampere current source. Okay, like for example, you can go down in to the level of current, the charges of the current, and say some of these charges basically because of like the 40 volt voltage source, and some of these charges is because of the 9 ampere current source. Okay, so each source contribute to the power consumed in any one of these resistances. So, for example, in this circuit, let's assume we want to determine Ix, and Ix is the current that is flowing in the 4 ohm. Okay, this guy here. Okay, so we can say theoretically that Ix is equal to Ix1 plus Ix2, or basically two components because we have two sources. Okay, where Ix1 is because of the 9 ampere current source, and Ix2 is because the 40 volt, the 40 volt, voltage source. Okay, so we are saying now that if we could determine Ix alone and Ix1 alone and Ix2 alone and add them together, okay, we can find basically Ix. Okay, so I'm gonna solve this, this circuit in here in two ways using the superposition, which is basically the main purpose of this, like video, and then solve it with another solution, like current divider, for example, and we should find that the two solutions, match each other. They must match each other. So let's start by doing that. Okay, so I'm gonna solve it first using the superposition. Okay, number one, using superposition theorem. Okay, so we wanted to find Ix1 and Ix2, two separate components. Okay, Ix1 is coming from the 9 amperes. So that means to find Ix1, we should only keep the 9 ampere current source and kill or remove the 40 volt, voltage source. So for Ix1, we should keep the 9 ampere current source and kill or remove the 40 volt voltage source. Okay, kill means or remove means cancel its job. What is the job of a voltage source? So the voltage source, like for example E here, have two terminals. The negative terminal, let's call it V minus, and the positive terminal, let's call it V positive. So a battery or a voltage source, what it does, it is basically raises positive voltage by E, in reference to the negative voltage. That means V positive will be equal to V negative plus E. Okay. So if E is zero, that means there is no voltage difference. If E is zero, so that will be negative, V negative. So in that case, when E equal to zero, that means V positive is equal to V negative. Okay. So what is meant by E equal to zero? There is no voltage difference. And what is the thing that we learn about that has no voltage difference? It is a short circuit. correct? So basically, to cancel voltage source, short it. Okay, so we're gonna put the short circuit on the voltage source. Okay, so we're gonna have the same circuit. Let's basically copy and paste it. So I'm gonna now short the voltage source. So we're gonna make a short like that. Let's make it with below, for example. So there is no more 40 volt. Okay, actually we can just delete it. So delete it and put short, instead of it. This is a short circuit. So that's short circuit. Okay? Because the short circuit, any point in the short circuit has the same voltage. It's one node. Okay? Now our circuit has just one source, and this IX now is called IX1, not IX. Okay? That's very good. Now using the current divider, we can find IX1. So using the current divider, we can get IX1. IX1 will be equal to the 9 amp, or let's call it just 9, not to confuse anyone. So is the total current here is 9. The total current is going in 3, will be branched into 3 branches. So, and we are interested in IX1, which is the middle branch. So IX1 is equal to 9, multiplied by the 2 other resistances, which is 2 parallel with 8. Okay, divided by the 2 parallel with 8 plus 4 ohm. So we need 2 parallel by 8. So we can just determine this using our parallel resistor calculator. I'm going to show it to you right now. So here it is. We have 2 resistances. One is 8 ohm. The other one is one is 2 ohm. The other one is 8 ohm. We press calculate. It's 1.6. Okay. So IX1 equal to 9 multiplied by 1.6 divided by 1.6 plus 4. Let's calculate this. So actually I have it here because I just solved this before before this tutorial. So yeah, 9 multiplied by 1.6 divided by 1.6 plus 4 is basically 2.571. Okay, that's IX1. Now let's determine IX2. So I'm gonna maximize again. So number 2, or this is here number 1, number 2, IX2. Let's even make it with another color so you guys determine easily what we are talking about. Okay, for IX2, IX2 is the one or the component that is coming from the voltage source. So in that case, we must kill the 9 ampere. Okay, so here for IX2, we're gonna keep the 40 volt voltage source and kill or cancel or remove the 9 amperes current source. How to cancel a current source? Same concept as the voltage source. Just cancel its job. What is the job of a voltage source? In the beginning, it makes a voltage difference. So if you make it a short circuit, there will be no voltage difference. Now, what is the job of a current source? It makes the branch in which it's connected have a constant current. So it basically it generates a current. So to make to cancel its job, you have to make this current 0. How to make a current 0? Make an open circuit. Very easy. So we shorted the voltage source to cancel its job. We will open circuit, the branches that has a current source to cancel its job. So basically, let's redraw again the circuit. Here is the circuit. I'm sorry. Okay, here is a circuit. Now let's cancel, the current source. How to cancel the current? Make an open circuit. Very easy. Just bring eraser here and make an open like that. So that branch now doesn't have a 9 ampere. Okay? Actually, you can just remove the branch. You can just omit, delete it completely. We don't need it anymore. So we're gonna end up with that circuit here. Okay? So let's now learn, you can solve it very easy. But I wanna teach you another concept that you can convert a voltage source to a current source and a current source to voltage source. Okay, you can solve it using the voltage source, no problem at all. But just to teach you something more, I'm gonna teach you also how to convert a voltage source into a current source and vice versa. So if you have a voltage source like this, or in general, like for example, let's do this with a red color. So if you have a voltage source with a resistor RE, you can convert it to a current source like that between the same terminal. This is called A and B, A and B. So this will be a current source, but the resistance will be in parallel between the same terminals. Okay? The condition here to convert is to have a resistor. Okay? So, so what is I here? We know R because it's the same R, the same resistance, no change. But what is I? I is very easy. E divided by R, just like Ohm's law. Okay, and why I'm doing that, I'm gonna show you now. So in here, I'm gonna convert this voltage source, 40 volt and the 8 ohm into a current source. So this is the 8 ohm, and this is, by the way, IX2. It's not IX, because IX2 is because of the 40 volt only. Then we have the 4 ohm. And now I'm gonna take the 8 ohm and the series 40 volt and convert them into a current source and a resistor in parallel. The resistor will be the same. The current source will be the voltage divided by the resistance. So 40 divided by 8 is 5. So this is 5 amperes. Okay? That's very good. And same. And where is IX? IX is the 4 ohm, IX2. In this case, IX2. Okay? And why I did that? Just to compare it to the previous circuit. It's the same, correct? But you just moved the current source from the left to the right. Doesn't change because we don't care about geometry. We care only about the connection. Actually, you can draw the circuit and you can redraw it and put the 5 amperes that we just converted from the voltage source into the left. Very fine. It will be exactly the same. What was the value will be different, 5 instead of like 9 in the first case. So IX2, just to continue now, IX2 will be so the total current is 5 here, will be branched into 3 branches. Okay, we are interested in IX2, so IX2 will be the total current, which is 5 multiplied by, it is flowing in the 4 ohm. So the numerator will have all other, resistances in parallel. So the 8 parallel with 2. So 8 ohm parallel with 2 ohm divided by 8 ohm parallel with 2 ohm plus the 4 ohm. And if we look back here, we exactly have the same equation, but with different. So it was 9 multiplied by 2 parallel by 8 divided by 2 parallel by 8 plus 4. So that here is exactly this one. We just change, the current value. Okay, so basically we're gonna use the same calculator again. Here is the calculator, so I'm gonna take this one here, copy, and just change basically the 9 into 5. So that will give us, so that's basically the same, 1.42 amperes. Okay, so now you can add IX1 and IX2. I'm gonna do another trick here to get like exactly the same as the right answer. So we have already, the calculator. So I'm just, take that part because ix is ix1 plus ix2. This is here ix1, this is ix2. So I'm gonna also, divide them directly in the calculator here. So this will give us 4 ohm. If you would add this fraction to the other one, it will not be exactly 4 ohm, but that's fine. Rounding is acceptable. Rounding is very acceptable. If we get it like 3.95, it's very okay. Okay, but I just, another trick that you get exactly the same, the model answer basically. So ix equal to ix1 plus ix2. So that will be 4 amperes. Okay, guys. Now, before we go, let's, find out ix, without using superposition, using the principles that we learned, Ohm's law, Kirchhoff current law, Kirchhoff voltage law, and see if we should get 4 again. Of course, we must have 4. Otherwise, your solution will be incorrect. One of them, of course, or maybe 2, both of them. Okay, so let's find out. So I believe so let's have another solution. So solution 2, using, Ohm's law, Kirchhoff current law, Kirchhoff voltage law. See if I have this. I don't have it. Yes. So let's just redraw the circuit again. Okay. So that's the circuit. The best way here is to convert again the 8 ohm and the series 40 volt into a current source. I'm going to show you why now. So we have here the 9. We have the 2 amperes. We have the 4 amperes. Then we're going to have the 8 amperes and the current source that comes from the conversion. This current source will be 40 divided by 8, which is 5 amperes. And here we have 9 amperes. This is 2 ohm, 4 ohm, and 8 ohm. Remember, we need Ix here. Okay. Now I'm gonna do a little trick. So basically, because we only care about the connection. Okay. So basically, I can redraw the circuit that way. I'm gonna take this guy and put it on the left, like that. Also, let's remove first, this mess. So that's 9 amperes. And that's the 5 amperes. Why I did that? To make it easier for you. I can just solve with this circuit here. It's very okay. But just to make it, more imaginable for you, that this current in here is 5 plus 9, it is 14. 14 amperes. Okay? And we need, again, Ix. So this 14 ampere will be branched into 3 branches. So Ix is equal to 14 multiplied by the 2 other resistances, 2 parallel with 8 divided by 2 parallel with 8, plus 4. Before we calculate this, I want to use the calculator that we have because we have already the answer. So let's look at the calculator. So we have 2 parallel by 8 is 1.6. We know this from the parallel resistance calculus. This is 1.6. This is 1.6. And look, guys, here. So 5 multiplied by 1.6 divided by 1.6 plus 4 plus 9 multiplied by 1.6 divided by 1.6 plus 4. So we can take 1.6 as a common factor, correct? Let's do this here, So we're going to end up with 5 plus 9, which is 14, right? And that will give us, again, 4 amperes. Okay, that's basically the trick. So that's basically here 4 amperes again. Okay, so we didn't do anything. Actually, when we solve using, the Ohm's law, Kirchhoff current law, and Kirchhoff voltage law, which will result in the current divider rule, because the current divider rule is based on these laws. Okay, we get basically, the same answer. So 14 here is 9 plus 5. And that's what exactly what we have done. What we have done before. 9 and here was 5. And 9 plus 5 is 14. Okay, guys, that was it for the superposition. Thank you very much for watching and see you in another video. Bye-bye.